Welcome to Fountain and Drinking Water. Water filtration is of significant importance to fountain dispensing. And the basics of fountain dispensing is the system has a carbonated water line, then a bag-in-the-box system, or some system provides syrup to the dispense point. They travel through separate lines and are mixed with a specific ratio set by different flow restrictors in these dispense heads to set up a ratio of 5:1 water to syrup, or a Brix ratio of 5:1, and it's mixed at the dispense point in the unit right before the cup. Now, if we change the percentage of water or the speed at which water is hitting this point, we are going to change that ratio. And that has significant impact to the profitability of fountain dispensing. There are essentially two types of fountain dispensers out there presently. One is a standard post-mix system. Post-mix means at the dispense point, with a standard bag-in-the-box methods with a 5:1 ratio. Water quality is important, but it can be masked by Brix changes. So by changing the ratio of the dispensers, they can add more syrup, covering up for poor water quality. But that's a mistake, and it can be an expensive one for someone selling fountain beverages, because that cuts directly into the profitability of the bag-in-the-box system, because you've changed this ratio. You've now lowered this below 5, using more syrup per beverage than you normally would, driving up costs. And then there's the high-yield units, such as Coke Freestyle, that have a Brix ratio approaching 50:1. So instead of 5 parts of water to 1, we're using 50 parts of water to 1 part syrup. This means the syrup is very, very concentrated, and these cartridges have flavors based with neutral sugars. And they basically come in cartridges similar to that of like inkjet cartridges. So a minor change in volume of water hitting the dispense point can cause significant taste impact from the Brix ratio, but more importantly, the amount of water we're using is 10 times as much. So that water, the taste of that water is going to have a much larger impact on the taste of the beverage. Other fountain dispensers, frozen carbonated beverage dispensers, are out there. They use bag-in-the-box technology as well, and they mix water and syrup, and that ratio is in that standard 5:1 ratio, 5 parts water to 1 part syrup. So the elements of a standard BIB system, bag-in-box, you have the water supply coming in to a carbonator, which is supplied CO2 from a tank. Water and CO2 are mixed inside this vessel, and then it is pumped out to a refrigeration system. And this is important to keeping the beverage carbonated, because gases are more soluble in cold water than hot. If you heat up a carbonated beverage, the bubbles come off easier. You probably don't notice the difference between opening a cold soda and a warm soda, the difference amount of CO2 released. That's the reason for that. Then you have the syrup supply. In this case, it's bag-in-the-box. And then you have the dispenser, where the water and the syrup are mixed into the cup of the customer. Now, carbonation basics. Essentially what you have is the incoming water being sprayed into a mist through a environment or a layer of CO2 gas. This mist picks up and dissolves that CO2 gas, falls down in here, and becomes carbonated with CO2. Now, the pumps that are associated with carbonators are carbon veined and water lubricated, they can be broken very, very easily by running those pumps dry. So keeping a consistent flow rate to these pumps is paramount to their life. Have you ever been back a house with a dry carbonator pump running? It creates one heck of a racket and can be easily heard front of house. So the water comes in, sprayed and mixed with CO2, is collected in the bottom of the tank, and then is pumped out via that carbonator pump to the bag, to the dispense point at the dispenser. Well, how water impacts fountain beverage? Well, we have solids, turbidity and cysts and things like that. Well, turbidity is going to potentially clog dispense point fine holes and things like that, or filters, or even cause abrasion to mechanical wear parts like the vanes of the pump. Turbidity also gives a spot for CO2 to form on and turn back into a gas, so it will reduce carbonation. You can probably tell the difference easily if you put sparkling water in a brand new clean glass versus one that's been washed in hard water a bunch. The one that's in the hard water, that carbonated sparkling water, is going to have a lot more bubbles clinging to the surface of the glass that has some scale buildup than a perfectly smooth new glass. And then there's the health effects with turbidity, that there could be possible cysts, bacterial cysts hiding in that cloud of turbidity that would impact health potentially. So you want to remove those with filtration as well. And then there's chlorine and chloramine removal, and taste, odor, and color are the total organics in the water we want to remove as well, because chlorine and chloramine have significant impact upon fountain beverage taste. And the first place you'll really notice this is in diet beverages. The chlorine and chloramine react with those synthetic sugars to produce a rather strong off taste. And then there's the organics in the water, the taste, odor, and color, that all have significant taste odors associated. If you think of a lake with all the decaying vegetation at the bottom of it breaking down and drawing some of that swampy stuff up into the water supply, that's where we get taste and odor impact from surface water sources. And then there's dissolved solids and gases. If we have high levels of dissolved solids, that mineral content can impart taste to the beverage. So we really want to manage those flavor profiles in extreme TDS situations. And then elevated alkalinity. Well, alkalinity is the bicarbonate buffer system. And what that does is it resists pH change. And when you bubble CO2 through waters that are very alkaline or are very hard, what happens is instead of creating carbonic acid, that acid is used up by the water, by the alkalinity buffer system, trying to change that pH. So you don't get the level of pH change in the carbonator as quickly, or you need to boost the level of carbonation to add more CO2, driving up cost, and you can result in a flat, chalky taste to the beverage, because not only is it neutralizing the CO2, that residual alkalinity may also impact the acid components of the syrup flavorings. If you think about lemon lime sodas with their citric acid and colas with the phosphoric acid, if we have a buffer in their Tums neutralizing that, we're going to get a chalky bicarbonate taste in that water and in that beverage. How water impacts high yield systems. Well, small changes in pressure dramatically impact that Brix ratio. If we drop the amount of water we're delivering in a 50-to-1 ratio scenario, that small change drastically throws off that Brix. Well, change in Brix significantly changes that product quality, and you're using much more of this concentrated syrup in that same beverage, driving up expense for those replacements of those Brix cartridges. And Coca-Cola, with their system, requires a dedicated line to their Freestyle, so it has its own supply, hopefully with less impact from the rest of the water infrastructure or supply infrastructure in the rest of the building. Water quality around these systems. Coke requires the freestyle approved filtration, which is chloramine filtration, at the appropriate flow rate for that unit. You'll be able to see the Coke Freestyle Guide for approved systems, and it must be rated for chloramine reduction because Coke is taking the stance we want chloramine filters everywhere to make sure we cover our bases on whether or not that system uses chlorine or chloramine, and that if there's a change mid-process, it won't impact our product quality. Well, high yield means less syrup, and less syrup means off tastes show up easier. So we really want to make sure we have a high quality water going into our high yield dispense systems. Typical water quality for fountain beverage is really similar to the Federal Safe Drinking Water Act, except for a couple things. Alkalinity, under 150 parts per million, and this is to facilitate better carbonation and less of an impact of alkalinity on the acidulants and acid flavor components of the syrups. Turbidity is lower than federal standard of 1 as well to keep carbonation up and quality of the taste of the product up as well. And they want the water free of off taste and odor, which essentially means carbon filtration. Now, Coke Freestyle, required use of chloramine filtration. Why? Well, high yield syrups are especially sensitive to off taste. Well, the carbon in chloramine filtration is a special activation process that creates significantly larger number of activation sites than standard activated carbon. This allows this to readily remove chloramine, but also gives it greater surface contact with potential taste and odor compounds as well, removing them more efficiently. And chloramines react differently with cartridge-based flavors than chlorine, and you'll really, really see a strong impact in your diet beverages first. So if you walk in and someone's mentioned they've got beverage issues with taste the diet and see how off that is compared to what you would expect, and that'll show up, those taste and odor issues will show up along with the Brix ratio issues very, very quickly based on those synthetic sweeteners. It requires a dedicated water line. No combination filtration systems are allowed here. No high flow CSRs. You'd have to have a dedicated filtration system just for the freestyle. Why? High yield beverages have high Brix ratios. We want to maintain consistent, even water flow and pressure to these units. So we don't want that experience of taking a hot shower and somebody flushing the toilet and all the cold water going away and that pressure drop. Well, that pressure drop in this case is our carbonated water, and the hot water where we get scalded with is the Brix ratio. You suddenly get a massive increase in one over the other because that cold water is pulled off in another direction. That same sort of impact happens to beverage equipment. When you have that pressure drop in the system and you pull water away from it, your ratio drastically changes. Now, filtration technologies that we use for fountain beverage. We use the MC and the XC filters in municipal water with water specs within range, and it's municipal sanitized water. They remove taste and odor compounds and ensure optimal performance and taste of that system. They're half micron persistent bacteria protection, and it's a pre-coat NSF certified 42 and 53, and up to 48,000 gallons in a quad. Well, the FC series is the same sort of water that we're dealing with the MC and XC2s, which is acceptable water quality for fountain beverage and from a municipal sanitized source. They remove the same sort of contaminants as the MC and XC2. do, but they're more for high capacity needs or high volume needs. Because of the Fiberdyne technology, we're able to get much bigger flow rates and much larger capacities. Half micron ratings, NSF 42 and 53, just like the MCs, but up to 100,000 gallons and a significant increase in flow rate over the quad systems. Then we have chloramine reduction filters to match to the Coke Freestyle systems. We have the 7CLM+, which is specifically designed for chloramine removal being present. With a Coke Freestyle, this is mandated whether it's chloramine or chlorine. And it is excellent at removing off-taste odors and chloramine from that system. It's a quick change filter, half micron, NSF certified up to 32,000 gallons. Then we have the bowl drop-in style filter series of the CV20 systems. These are for mineral content within beverage quality, but for chloramine specifically removal. And same sort of performance as the 7CLM, but for high capacity needs. It's a drop-in technology, half micron, NSF certified, and up to 85,000 gallons in a quad. Now, for combination systems for fountain beverage, for especially high capacity and high peak flow rates, we're looking at the endurance systems. It's from mineral content within proper ranges and disinfectant present, but with high dirt load or high volume use. You know, we may have a small amount of dirt in that water, but the amount of water that that establishment may use in 6 months to a year is so heavy that that dirt builds up quickly just through volume of use. And these systems are up to 200,000 gallon capacity in a quad and up to 15 gallons per minute peak flow rate. NSF 42 and 53, and it's a true combination system. You can have fountain on one port, ice, coffee, tea, and other applications on the SRX phosphate feed system. Please note that a Coke Freestyle would have to have its own separate system. We could not use this for a Coke Freestyle. And if you have an existing system already in the wall, we offer the ability to upgrade that existing twin, triple, or quad manifold to the endurance kit, going from the standard cartridge life up to the potential 200,000 gallon capacity with higher flow rate. And this kit just allows us to swap out the filters, install a 2SRBW feeder, and the pre-treatment before these filters. We have a manifold that's specifically designed around Coke Freestyle issues for a smaller package that delivers not only the chloramine filtration, but also ice filtration as well, with 2 dedicated lines. So we have a dual inlet, dual outlet. That's what DO stands for, dual inlet outlet manifold. And this is for pressure sensitive applications like Coke Freestyle, where we have 2 separate water lines brought in and 2 separate lines brought out. The back one will hold 3 7CLM plus cartridges for the Coke Freestyle, and then the front 2 will hold a choice of ice filtration cartridges, whether those I2000s, 4000s, 7FC5, 7FC-S's, or even 7SIs feeding the ice maker. So when one unit kicks in, it's not spilling water from the other portion of the filtration system. And also the manifold is available by itself, so you can use it in other applications if you had pressure sensitive issues or you just wanted 2 water qualities that you could change out separately, but in a small compact manifold. So sizing filters for fountains. We need to answer 7 questions here. Is this a high yield or standard fountain system? Coke Freestyle versus standard bag-in-the-box. How many carbonators are there? Because a carbonator requires a minimum flow rate of 1.67 gallons per minute. if you've noticed, that number shows up on our flow rate with our MC and our XCs cartridges. That wasn't by accident. Those filters were designed around this application. How many carbonators are going to determine what sort of flow rate, peak flow rate you need. Now, do you have low pressure, low dynamic pressure, below 50 psi in the building? That is going to determine whether or not we need a water boost to maintain that consistent water pressure and flow through the filters to our fountain dispensers, because that greatly impacts profitability. So dynamic pressure is when a tap is opened and running. What pressure do you have there? Do we have a non-carb pump that we have to satisfy? Well, for non-carbonated beverages like lemonade and iced tea or fruit punches, those sorts of things. And how many bag-in-boxes do they go through per month? This is going to help us understand capacity. If we think about a bag of box of syrup and we're putting in 5 times the amount of water, if we have 100 gallons of BIB that they go through in a month, well, they're going to go through 5 times that in the water, so they would be going through 500 gallons of water. So you need to size the system appropriately to how much water they're being used. And is there other water-using equipment that can benefit from a combination system? Remember, if there's a Coke Freestyle, it must have a dedicated line. But if you're dealing with standard BIB, can you use a combination system to handle the iced coffee and tea in the location as well, giving them more value than just fountain filtration? And the last thing, is the plumbing adequate to feed peak flow demand? So we want to match the line size coming in at 3/4 of the line size going out. And we can reduce that line size afterwards if it meets flow demand of the building. If not, let's maintain that 3/4 in and out until we break down to the trunk lines and pieces of equipment. So let's review an installation to understand basic mistakes that are done with these systems. So we have a high-flow CSR quad, and it's plumbed to ice machine, coffee, and tea, and also to fountain. Well, what's wrong here is that we do not want to provide phosphate to fountain beverages. Phosphate will cause an off taste, and on top of it, it will cause the beverage to go flat because phosphate will act as a pH buffer, wiping out the carbonation. So these 2 ports are reversed. We want to feed phosphate to ice machines, coffee, and tea. So these lines need to be reversed. That's what's wrong with this installation. Well, what's wrong here? Well, we have a cold drink 2 7 CLM version, and it's feeding a Coke Freestyle and a tea dispenser. Well, Coke Freestyle requires a dedicated line, so we would have to split off this tea brewer and put it on its own separate filtration system to meet Coca-Cola's requirements.